Do you notice anything unusual about this road? Probably not. The customary early spring scene, snows melting, roads wet, lots of potholes, same as every other year. Unfortunately, this is a common scene. Potholes are perceived to be a perennial problem, not only by the driving public, but by many people involved in road work. This does not have to be. There are no mysteries about potholes. We know what causes them. We know how to properly repair them. And most importantly, we know how to prevent them. In the next few minutes, we'll take a close look at potholes, their causes, cures, and prevention. Our earliest roads began as paths or trails that were widened to accommodate wagons. These wagon trails eventually evolved into gravel roads, much like our back roads of today. Even without pavement to break up, such dirt roads are plagued by pothole formation. Many areas have poor drainage, and where water collects, the roadbed becomes saturated with moisture. As traffic passes over these localized saturated areas, the soil fines are washed away, and a hole develops. Though the chain of events is somewhat different in paved roads, the basics of pothole formation are the same: traffic and water. You will not find pothole formation unless both are present at the same time. Potholes in paved roads usually begin when the ground temperature falls below freezing. As the pavement gets colder, it contracts, and small cracks may form. As the temperature of the pavement falls and rises in winter's daily cycle, these cracks widen as they are repeatedly opened and closed. The widening crack now admits any surface water, it may be rain or snowmelt, causing a localized zone of saturated base material beneath the pavement. Following this thermal cracking and water entry, other mechanisms further deteriorate the road surface. As the daily freeze-thaw cycle continues, the water now permeating the road base freezes and causes uplifting or tenting at the cracks. This again widens the cracks as well as creating new ones. In addition to causing tenting, this area of water-saturated base now offers little support to the pavement above it. So as traffic passes over the saturated zone, the pavement deflects down and up. Under repeated loading, the thin pavement layers and, eventually, the underlying saturated soil are scattered from the area of deflection. Manholes, catch basins, water valves, and other fixed structures are especially troublesome points. Pavement contraction can open cracks at the joint between the structure and the road surface, allowing water entry. Again, the combination of excess water, the freeze-thaw cycle, and traffic result in potholing. Spring thaw. Gradually, the air temperature rises. Everything begins to warm. The sap begins to run. Gravel roads turn to mud. Pavements try to shed the excess moisture drawn to the surface during winter's freezing cycles. This thawing period we call mud season lasts 2 to 4 weeks. Beneath the road, the pockets of ice which have formed during the winter are thawing from the top down. The frozen soil below does not allow drainage, so water must drain upwards through cracks in the pavement or laterally close to the surface. During this time, pavements are very weak and are easily damaged under heavy loading. Truck weight restrictions should be enforced at this time to prevent unnecessary destruction. Excess moisture, cracked pavements, and traffic. Spring is a most trying time for our roads. Potholes are everywhere, and road crews struggle to keep up with them. At this time of year especially, it seems that there is never enough time and money to fix it right the first time. But there's always enough time and money to do it over and over and over again. There is a way to break this cycle. If a pothole is repaired correctly, the patch will probably outlive the original surrounding pavement. First, the hole should be squared up with vertical sides and undercut, cut deeper than the existing pavement. The hole should then be cleaned of all debris, dried if it's wet, and the base compacted. The sides should be coated with a liquid asphalt tack coat with a brush or spray bar. A hot asphalt material should then be applied in layers. It may be hot asphalt concrete, heated recycled asphalt concrete, such as chunks of pavement from utility cuts, or cold planed asphalt concrete, or it can be heated cold mix. The top lift of material should overfill the hole so that after compaction, the patch will be flush with the surrounding pavement. A seal around the perimeter of the patch should then be applied to protect the joint. The best way to cure potholes is to prevent them from occurring in the first place. A good preventive maintenance program should be set up in each municipality or military installation. The following is a suggested pothole repair program. Train a pavement maintenance supervisor to recognize problem areas in your town or city. Conduct an inventory of your pavement system to rate the condition of each street. Develop a maintenance schedule based upon the inventory. Establish a regular program of crack sealing and surface treatment. 4. Provide separate budgets for snow removal and road maintenance. Establish a normal program of inspection and removal of debris from drainage ditches and structures. Equip your pothole repair crews to blow out, sweep, or otherwise remove water, and to dry and prepare the hole. Ensure successful repair through, first, proper hole preparation, and second, proper compaction of materials. Repair potholes in the summer as much as possible, based on a year-round monitoring and the inventory. Use proper materials and procedures in good weather for permanent, one-shot repairs. Develop a first-class, strictly enforced system of coordinating improvements to underground utilities with the street resurfacing program. Establish a system making the utility responsible for the care and maintenance of a patch for at least a year after a pavement cut. Maintain your pavements on a regular and proper basis to protect your investment. Obviously, the best way to minimize potholes in the first place is to construct roads properly. A free-draining, non-frost susceptible base is vital to proper drainage of water from beneath the pavement. In addition, several inches of gravel will allow passage of water to drains along the edge of the road. The base course must be thick enough so that the pressure of heaving in the subsoil will be spread evenly, thus preventing bulging and breaking of the pavement. Water from the melting ice lenses must also be able to drain upward into the clean, porous base, so that it can then travel laterally to the roadside drainage system. A thick base course is also necessary for the wide distribution of the traffic load over the weakened subsoil, so that its support capacity is not exceeded. A thicker pavement will also go a long way toward preventing potholes. At a pavement temperature of 70 degrees and using 0.12 of an inch deflection as failure, we have found that a 1-inch pavement can carry 100 pounds, 2 inches 400 pounds, 3 inches 1,200 pounds, and a 4-inch pavement can support 3,800 pounds. Just going from a 2 to 3-inch pavement, load bearing is tripled, or by adding yet another inch, 9 times the 2-inch capacity is achieved. In fact, the vast majority of potholes occur in pavements of 2 inches thickness or less. Thicker pavements still deflect and crack over a weakened area, but because of their depth, they behave like a jigsaw puzzle. The pieces interlock. Thin pavements cannot interlock, and so failure occurs very dramatically. The Cold Regions Research and Engineering Laboratory of the United States Army Corps of Engineers has developed a special report titled the Pothole Primer. This 24-page booklet was prepared with the specific purpose of assisting elected officials and non-engineering administrators of cities, towns, and military facilities in understanding and managing their pothole problems in asphalt pavements. It is as non-technical as possible so that non-engineers can use and understand it. This special report, number 81-21, is available free by writing to the Krell Publications Office at 72 Lime Road, Hanover, New Hampshire, 03755. Another Krell publication, this one a technical digest, is titled The Engineer's Pothole Repair Guide. It describes various pieces of equipment and materials that can be useful in repairing potholes. Both are available through the publications office. We can fix potholes and do it very well. The information and technology are available. Protecting our sizable investment in good roads requires committing the time and resources to properly repair failures and develop a good preventive maintenance program.